This lesson is key features of functions, and most importantly we're going to focus on domain and range. So anytime you see key features, this could talk about different things: domain and range, increasing, decreasing, vertex, all that stuff. So it's just talking about different things on a graph. So we're going to focus on domain and range. So our learning target is I can find the domain and range of functions. Alright, so let's go over some stuff from previous math courses. So there are 4 inequality signs that you've seen before. Some people have trouble with these. So the first one is the less than sign. It looks like a squished down L. So if you get confused, the one that looks like a squished down L is the less than. So an example, we could do like 2 is less than 3. And probably in elementary school you've heard of the alligator eats the bigger number. So the alligator is going to chomp on the 3 because it's bigger than the 2. It's a hungry alligator. Alright. The next one is the greater than sign. So something like 3 is greater than 2. That would work. And then the last 2 have that extra bar underneath it. So anytime you see that bar, it means or equal to. So when you look at this one, this is less than or equal to. So 2 is less than or equal to 3. But you also could do something like 3 is less than or equal to 3. Because it could be less than or it could be equal to. That's the whole point. And then the last one is greater than or equal to. So 3 is greater than 2, greater than or equal to 2. Or you could also possibly do 3 is greater than or equal to 3, because 3 equals 3. Okay, so that should not be new information. That should be from elementary school. Okay, and then you learned how to graph things on a number line. So if I look at this first one, less than is when you would use the open circle. So I don't know if you remember this, but we'll go over it. So our example is x is less than 2. So we would have an open circle at 2, and then we would shade anything that was less than 2. So it's an open then circle because it's less than or not equal to, and then we're going to shade everything that's less than 2. The next one, we're going to look at greater than, also an open circle. So if it's open, it means it's not going to be equal to. So we would do an open circle at 2, and then we want anything greater than 2, so we would shade everything greater than 2. The next then, we have less than or equal to. So this is when you do the closed circle. So it's closed anytime it can equal that number. So I'm going to close it in because it can be equal to 2, and then I'm going to shade anything less than 2. And then last one, we're going to do greater than or equal to. So also a closed circle because it can be equal to 2. And then we're going to shade everything that's greater than 2. Okay? So hopefully that gets some information back in your head if you had forgotten it. Okay, so you've probably seen this before. The domain is the set of all x values. So if you ever forget this, I want you to think about the x-axis is this one. It goes from left to right. So domain really means like how far left and right the graph goes. That's how we're going to think about it. Range is the set of all y values. So the y-axis goes up and down. So it's how far up and down a graph goes. So in the past you've been talking about all x values, all y values, but you could also think about domain being left and right and range being up and down. And we'll do some examples. So we talked about how you can use just a simple Desmos calculator if you want to do that. Go to desmos.com/calculator and type in this function, the absolute value of x minus 3, and then plus 2 on the outside. Or what we could do is just make a little table. So that's what I've done right here. I've made an x and an f of x. So remember, f of x is the same thing as y. We want to use f of x because we're talking about a function of x. Okay, so what I'm going to do is I'm just going to choose some values for x. So I'm going to do, I don't know, let's do -5, -3, -1, 0, 1, 3, 5. Just enough so that we can see what's happening at these points. And so what we do is we're going to change this x to the value that we have selected. So like the first one, we're going to place that x with a -5. So -5 minus 3 is -8. Anything inside an absolute value becomes positive, so it's a positive 8 plus 2. So 8 plus 2 is 10. Okay? And what we're going to do is replace that x with these other values, -3, -1, 0, 1, 3, and 5. And then we're going to get another answer, and that's our f of x. So I want you to go ahead and try it. You can pause the video, and then you can check your answers with me. Okay, so that's how you get a table of values if you don't have a calculator. Okay, and remember that this graph keeps going left and right forever. So when we talk about the domain stretches to the left forever. So you have the values, the domains 5, 3, 1, 0, -1, -3, -5, and it keeps going on, like -10, -5,000, -500 million. So what we say is that the domain is everything to the left axis. And then also it keeps going to the right forever. And it keeps going to like 10, 10 million, 10 billion, keeps going forever. So there's not a single x value that this graph isn't going to have in it somewhere. It keeps going left forever, it keeps going right forever. So what we say is that it has all real numbers. Okay. The range is a little bit different. The range definitely stops going down at a certain point. If you're looking at your table, you're looking for what's the lowest y value it has. So the lowest it ever goes is 2. But then it goes up to 4, 5, 6, 10. It's going to keep going up and up and up forever and ever. So really, the y is going to be anything greater than or equal to 2. Because the lowest it ever goes is 2, and then it goes up forever. So anything greater than or equal to 2. So that's probably how you've done domain and range in the past. We're just reviewing, and then I'm going to show you how we do it in Math 3. So let's try another one. So here's our function. You can go ahead and choose some values. I'm going to pause the screen and let you try that. 1, 2, 3. So what we have is we have a parabola, a quadratic. It definitely keeps going up forever, but it's also stretching out left and right. So if you'll notice the domain, it's going to keep going this way forever, keep going this way forever. So it's going to be another all real numbers. Because there's not a single x value it's not going to go through eventually. The range is a little bit different. So if you'll notice, the lowest the y value ever goes is 3. So right here. And then it keeps going up forever. So my y's are going to be anything greater than or equal to 3. Okay, let's do one more. Here's a square root function. We should have talked about this in Math 2. If you didn't, it's fine. It's going to work the same way. So go ahead and fill out your table if you want to. 1, 2, 3. Okay, so if you remember from a square root function, it definitely starts at a certain point, but then it's going to keep going on forever. Okay, so the domain is not going to be all reals because there's definitely an x value it starts with. Here's my lowest x because it starts right here. And then anything greater than that x. So my domain is going to be anything greater than or equal to -4. And then my range, it definitely is the lowest point right here at 1. And then it's not very steep, but it will keep going up forever as long as you zoom out a whole lot. So my y is going to be anything greater than or equal to 1. Okay, so now I'm going to show you how we do it in Math 3. We do something called interval notation. Okay, so interval notation looks like this. It's going to be like begin, comma, end. We're going to use parentheses whenever it would be like an open circle or a less than or equal to sign. So anytime it's not going to be equal to, we're going to use parentheses. When it is equal to, we're going to use square brackets. And that's for any time you would use a closed circle or you have these symbols, greater than or equal to, less than or equal to. So parentheses for when it's not equal to, it would just be greater than or less than. And then square brackets for when it is equal to. So I know it's a little weird. So let's look at the examples that we already did. So here's the example we did previously. There's the function. We said the domain was all reals. The range was y is greater than or equal to. And I drew a little picture just in case you forgot what it looked like. So we're going to do interval notation. So anytime we do interval notation, it's like the beginning and where the end is. So remember, domain, we're going to read from left to right. So that's basically what we're going to do. So we're going to say, what's the leftmost x coordinate? So if I keep going out here forever, remember, it goes all the way to negative 50 trillion. Negative blah, blah, blah. So what we say is that it really begins with negative infinity because it keeps going to the left forever. And then we want to say, what's the rightmost x coordinate? But it keeps going right forever, but it goes in the positive direction. So it goes to positive infinity. So in Math 3, this is how you will write domain whenever it is all real numbers. The range is a little bit tricky. The range, we're always going to do bottom, comma, top. So we're going to say, what's the bottom y value? So remember, the lowest it ever goes is 2. That's my bottom. And because it can equal 2, I'm going to do a square bracket around 2. It can equal 2, so it gets a square bracket. And then it goes up and up forever. So it goes to positive infinity, and that's going to be a parenthesis. Anytime you do something around an infinity, it's always a parentheses because you can't actually equal infinity. I can't give you infinity dollars. That would be nice, but I can't do it because it's not an actual number. But I can equal a 2. I can give you a $2 bill. Or I can give you two $1 bills. I can give you something that actually equals. So that's why you get the square bracket. Okay, and then we did this problem. We did the quadratic. We said the domain was all real numbers. The range was y is greater than or equal to 3. So remember, domain is going to be leftmost x value to rightmost x value. Because it keeps going to the left forever, and it would go all the way over to like negative 50 billion, negative 50 trillion, we're going to say it starts at negative infinity. And then the rightmost point, it keeps going right forever, it's going to stop with infinity. And remember, we're going to put parentheses around infinity because you can't actually equal infinity. So that's my domain. And then my range is from the bottom y coordinate to the top. So the lowest y coordinate is 3, and it can equal 3. We have that equal sign. And then it keeps going up forever, so positive infinity, and then we're going to put a parenthesis around infinity because you can't equal infinity. All right, let's do one more. So then we did a square root graph. Okay, so this domain is not going to be from negative infinity to infinity. It definitely starts somewhere and then stops. So remember, I'm going to do the leftmost x coordinate to the rightmost x coordinate. So the furthest left x coordinate is right here at negative 4. And it can equal negative 4. So square bracket negative 4. And then because it keeps going to the right forever, it's going to stop at positive infinity. And that's always going to get a parenthesis around it. Alright, and then the range. Remember range, it's a little weird. Bottom, comma, top. The lowest y coordinate it goes to is 1. And it can equal 1, so it gets a square bracket. And then it doesn't look like it, but that graph will keep going up and up forever. So it's going to go all the way up to positive infinity, and it's going to get a parentheses because you're talking about infinity. Okay, so the inequalities is what you did in middle school. Interval notation is what we do in Math 3. So it's a bit of a jump, but I have some extra practice problems that I went through that you can try, and you can always email me, set up a Google Meet, whatever you need to do if this doesn't make sense, and then if you just can't figure out the practice problems. All right, that's all, folks. Bye.